This project involves developing an AI system that detects emotions from text in real time, with applications in customer service, mental health support, business insights, and social media monitoring. The model was trained on 10,000 tweets labeled into 5 emotions, using 80% for training and 20% for testing. Text per processing included cleaning, tokenization, padding, and label encoding. The deep learning architecture uses an embedding layer, bidirectional LSTM, dropout, and a dense layer with softmax output. It achieved 86% training accuracy and 81% validation accuracy. While the model performs well, it struggles with similar emotions like sadness and worrying, and cannot detect sarcasm or ambiguous language. Future improvements include using transformer-based models like BERT, expanding the dataset, and enhancing the system's ability to understand complex emotional cues. Overall, the project demonstrates effective real-time emotion detection using NLP and deep learning techniques. This Python script is designed to serve as a live emotion detector that analyzes user input text and predicts the associated emotion using a pre-trained deep learning model. The implementation is done in Google Colab, and it begins by importing essential libraries such as TensorFlow, NumPy, Pickle, and Keras per processing utilities. TensorFlow is used to load and run the deep learning model. NumPy handles numerical operations like finding the highest probability class, and Pickle is used to load pre-saved Python objects such as the tokenizer and label encoder. The script also imports Google Colab's Drive module to mount the user's Google Drive, which is where the model and associated files are stored. After mounting the Google Drive, the code loads 3 critical files from it: the train model emotion_detection_model.h5, a tokenizer object tokenizer or .pkl, and a label encoder object label_encode or .pkl. The model is responsible for predicting emotions from preprocessed text. The tokenizer converts raw text into sequences of integers based on word indexes it learned during training, and the label encoder maps numeric class predictions back to emotion labels. For example, from to sadness, a function named predict_emotion text is defined to handle the full prediction pipeline. When a sentence is passed to this function, it is first tokenized into a sequence of integers using the tokenizer. Then, the sequence is padded or truncated to a fixed length max_length equals 150 to match the model's expected input size. The padded sequence is passed into the model, which outputs a probability distribution across emotion classes. The class with the highest probability is selected using np.argmax, and the corresponding emotion label is retrieved using the label encoder. The final part of the script runs a live loop that continuously prompts the user to enter text. Each sentence typed by the user is passed into the predict_emotion function, and the predicted emotion is printed out. If the user types exit, the loop terminates and the program says goodbye. This setup allows for real-time emotion detection, making it suitable for applications like sentiment analysis in chatbots, virtual therapists, or customer support systems.